Okay, now one thing we need to look at is what conventional current is. Um, Going back in history, we didn't always know about positive charges and negative charges. I'll show you a video in just a moment to kind of explain this. But what ended up happening basically through the history of science is that we talk about conventional current as the direction that the electrons, not that the electrons are going, but that the protons would be going if they were actually going anywhere. So if we think about a battery, I'll explain this in a few minutes, but what happens in a battery, we have a positive side and a negative side. So this is the symbol for a battery. The longer side is the positive end of the battery, the negative is the negative end. And we're going to connect it from one side to the other with a wire. So that's a battery, and then it's connected. And both ends of the battery have to be connected to that circuit to make it work. Well, charge wants to move away from the negative side and toward the positive side, right? This is the way the electrons are going. So if the protons could move, the protons would be going the other way. So the positive charge would go in this direction. So we define conventional current in that particular direction. So conventional current is going to go from the positive side of a battery toward the negative side. I'll explain that a little bit more later. But this is the conventional current. So that's the direction that we kind of pretend the charge is going, but in reality, the charge is actually going the other way. And thankfully, it turns out that doesn't really matter in terms of our calculations. We just need to make sure we distinguish between conventional current and which way the electrons are going.